What's going on, guys? Welcome back to the channel. We are talking about solving for equation today. So the purpose of the lesson today is to solve equation. So there's a couple of things here. Firstly, we talk about the language. The solve means you are solving for mystery, just literally the meaning of the word solve means finding X, which is our unknown here, finding X, um, finding the unknowns, which is X anyway. So usually we call the X is the unknown. Equations, right? So that's the meaning of the word solve. Now the meaning of the word equations means there must be an equal sign. Equations, equate goes from the word equate, mean equals, equate. And that's a verb. Equations are noun. There must be an equal sign somewhere. So that's the meaning. Finding X, finding unknown, from an equations. So the equal sign must be somewhere. Okay, so that's just a brief introduction. So we go straight to, a couple of introductory scenarios. If I go down and see here. So let's go over a first example. 2 plus 3 equals 5. Now we all know this from primary schools. 2 plus 3 equals 5. No debate about this. We use this a lot, when we count 2 plus 3, 2 fingers, plus 3 fingers, 5 fingers, that kind of thing. Let me just put this way. So let's say the 2 is missing. So we have a box where they have a question mark in it. Plus 3 equals 5. Now the question is, what plus 3 equals 5? So the natural way to think is think forward, right? It would be like, oh, okay, since I know 2 plus 3 is 5, so the question mark has to be 2. So this is what you'll be thinking in your head, but someone else will be doing this. Someone else will find the question mark and be thinking the opposite of that. It's working backward. So something plus 3 is 5. So that something's got to be 5 minus 3. So someone else is thinking along this line here. The question mark is going to be 5 minus 3, which will be 2. So yes, it does give you the same answers, um, but the second method is called working backwards. So we do exact opposite of what's been given to find out what's missing, which is the same as detective work. So the detective work is to unfold the story, to work backward and see who's the real culprit. So I'll say solving equations by detective work, working backwards. Just scroll down and write a thing down because that's what it really makes sense, right? So solving equations is actually detective work. Detective work, which also means you have to working backwards. There you go. So you try to unfold a story, you work backwards. We'll go over a few examples and you will see why. So instead of having a question mark, in general, if you're finding something, you call it X, which is the missing thing, and then you plus 3 equals 5. So in this case, in this scenario, we are finding X, example, right? You're finding X in this case. So to find X, it's real simple. You keep the X on the left hand side because we are looking for it, and we're gonna do the opposite of plus 3, which is minus 3. So 5 stays on the right hand side, and you move the 3 to the right hand side. So you move the plus 3 here, whole thing to the right side. So when you move the plus 3 to the The right hand side, you're trying to unfold the story. You're trying to do the opposite of +3, which is -3, right? So so when you move the +3 from the left to the right, you're actually doing the opposite of what is being given to you, which is +3. So the opposite of +3 is -3. There you go. So that's how you unfold a story. And therefore x is happily 2. And well, that makes sense, right? Because in your head you'll be thinking, all right, when x is 2, so when x is 2, so when x is 2, if you look at the original one, so 2 plus 3 will be 5. Yes, it's been verified. You see that? We can go over a couple more examples and you will see for yourself what I mean by working backwards. Working backward is one of the most important procedure in mathematics in order to figure out what's missing, what's the unknown. Since you don't know it in advance, so you're going to try to work backward and see what happens. Whenever you move something from left to right, you do the opposite operation. Now, okay, let's look at the another example, and you will be convinced that we're doing backwards now. So next example is this one here. Example. Well, that's example number 2, but just go example. Right, you got x minus say 5 equals 10. So now in your head you'll be like, oh, what number minus 5 gives you 10? Another easy question. Clearly the answer is 15. But let's look at the way we get the answer. Let's work backward and see what happens. Something minus 5 is 10. So I keep that something with this x on the left. The minus belong to 5. So I'm gonna circle this one here and I try to undo the steps here. I try to undo, put the minus 5 to the right hand side. So when I put the minus 5 to the right hand side, I am actually doing the opposite of minus 5, which is plus 5. Right? The 10 stay though. So 10 stay on the right hand side. There you go, plus 5. And therefore I have x to be equal 15. There you go. So well, that makes sense, right? Because in your head 15 minus 5 is 10. So it fits with the x from the beginning. So in your head, 15 minus 5 is actually 10. Bingo. That's the game over right there. Okay, let's go over another example. Now, this times we don't do adding or subtracting, we do multiplying. Let's see what we can do with that. Let's go down. Just bear with me. I have 2 more examples and things will become so much clearer to you. This is what we call one-step equations. We're literally working out the x, using the opposite operation. So another example we talk about this one is 2x equals 30. Here we go. So 2x means 2 times x. Because you don't know, the meaning of this one is 2 times x. So I'll write that question again. 2 times x equals 30. So surely in your head you'll be thinking, x is 15 because 2 times 15 is 30, right? So in your head you'll be like, oh, all right. 2 times 15 is 30. Easy. So x is going to be 15. But how about we gonna use the techniques we did above to this question? We're gonna apply the same technique, see what happens. All right, so I say 2 times x is 30. So the opposite of times is divide. So on the left hand side, I say 2 times x. So to find x, we have to do the opposite of times, which is divide. So we keep 30 on the right hand side, we divide by 2. Here we go. So 30 divided by 2 is going to be 15. Fits the bill. Fits everything. Here we go. So x equals 15 is game over. So again, you do opposite of what we know. 2x means 2 times x. Opposite of that was going to be 30 divide. So you do divide there. All right. So now we talk about the last example, which is dividing. So we've got example here. x divided by 3 equals 6. Surely in your head you'd be like, okay, so x divided by 3 is 6. So some number divided by 3 is 6. That number's got to be 18, right? Because 18, that's what you think in your head. 18 divided by 3 is 6. Now we do the opposite of dividing. To find x, we leave the x on the left. And we do the opposite of dividing, which is multiplying. So 6 stays on the right hand side. You times 3. Well, 6 times 3 is 18. Sweet. So you do. When you simplify something, you do the opposite operation of what you started up with. So x equals 18 fits the bill. Now it's a game over right there. We'll see you guys soon.